We can solve the following expression by rearranging the terms so that all the terms are on the same side. Here what I'm going to do is I'm going to move the following two terms over to the left hand side. If I do that, I'm going to get x cubed plus x squared minus 24x minus 24 equals to 0. And then I can factor this by grouping. I can take the first two terms and the last two terms and factor out the GCF. The GCF of the first two terms is x squared, which leaves me with x plus 1. The GCF of the next pair of terms is negative 24, which leaves me with x plus 1 equals to 0. And because these two binomials here are the same, we're able to rearrange the GCFs into a binomial like so, times x plus 1 equals to 0. And now what we can do in order to solve this, we can use the zero product theorem. That simply states that if either one of these terms, if either x squared minus 24 equals to 0, then the whole thing equals to 0. 0 times anything is 0. Or if x plus 1 equals to 0, the whole thing will also equal to 0. So what we can do here is we can now pull out the two binomials and set each one of them equal to 0, and then solve them for 0 to find the roots. So we have x squared minus 24 equals to 0, which is x squared equals positive 24, and x is then going to be square root of 24. Now we need to keep in mind that we have the positive and the negative roots, so it's going to be plus minus square root of 24. The radical has to be simplified. We can factor out a 4. That's the largest possible perfect square root of 24. And then we take the square root of 4, which will give us plus minus 2 times square root of 6. So that will be two possible roots, the positive and negative one here. And that is if x squared minus 24 equals to 0. The alternative is that x plus 1 equals to 0. And that will happen when x equals negative 1. So our solution here consists of 3 roots, like that.